Hello, and welcome back to another Orange Coast College mathematics video. In this video, we're going to cover absolute value functions and the shifting of them. If you're unfamiliar with how to shift graphs, I recommend you check out the other videos in our series. So, what is the absolute value function? Well, the absolute value function is shown here. It has these two little bars around x, and in a nutshell, what it means is that if I have a positive value, I'm going to keep it positive, and if I have a negative value, I'm going to then turn it into a positive number. Now technically, our function is actually a piecewise function. So f of x is equal to positive x if my x value is greater than or equal to 0, or it's equal to negative x if my x value is less than 0. So let's try this out in a couple numbers. The absolute value of positive 3 is going to be equal to 3 because I'm going to keep it the same. I'm going to do nothing to it if it's greater than 0. Let's try negative 3. So the absolute value of negative 3 is going to be equal to, well, what's my rule? My rule says that I'm going to use negative x if my x value is less than 0. And we can see that negative 3 is less than 0, so we're going to do a negative of that number. As in, we're going to do negative 3. But if I have two negatives, they're going to cancel each other out, and it's going to end up being a positive. So we're left with positive 3. So the absolute value of positive 3 is positive 3, and the absolute value of negative 3 is positive 3. So let's actually graph this function real quick. So if I plug in 0, I'm going to get 0. If I plug in positive 2, I'm going to get positive 2. If I plug in positive 4, I'm going to get positive 4. If I plug in negative 2, I'm going to get positive 2. And if I plug in negative 4, I'm going to get positive 4. So we can connect the dots and we can get a good sketch of our function. We can also see that if we look at our piecewise function on the right side of 0, right, when x is positive, I have a line with slope 1 and a y-intercept of 0. And if I'm dealing with values of x that are less than 0, I have a line with negative 1 slope and an x-intercept of 0, which is exactly what we see here. On the right side, we have a line with slope 1, and then on the left side, we have a line with slope negative 1. So let's move on down to the next problem. Now to start off, for shifting functions, I typically like to have a base function. Now we see that we're dealing with the absolute value, so I'm going to let f of x be equal to the absolute value of x by itself. Now when we're dealing with shifting functions, I like to write my function in terms of my base function so I can see what exactly is being done to that base function. So we can rewrite g of x as f of x plus 2 plus 3. So what is happening to my function? Well, I'm taking my input and I'm adding 2. So I'm shifting my function 2 units to the left. And now the other part is a plus 3. So we're going to shift my graph up by 3 units. So I like to graph my base function, so I'm going to do that real quick. So absolute value of 0 is 0, absolute value of 3 is 3, and the absolute value of negative 3 is 3. Okay, so I have the graph of my base function, and what am I doing to it? I'm going to shift it 2 units to the left and then 3 units up. So I'm going to take each of these points, move them 2 units to the left, and then 3 units up. So starting with the left one, we have 2 to the left, and then 3 up, That'll be right there. Then the origin, 2 units to the left, and then 3 up. And then finally our right point, 2 units to the left, and 3 units up. So now we can connect this and we have our graph. All right, let's move on down to the next one. So as always, I like to know what my base function is. I can see that we have the absolute value of x minus 1, so I know my base function is the absolute value of x. So I'm going to let g of x be equal to the absolute value of x, and I want to write my function in terms of my base function. So I can rewrite f of x as f of x equals negative 2 times f of x minus 1. So we have 3 things going on here. So first off, we have this negative sign. So what is this negative sign saying? It's saying I'm going to take all of my y values and then turn them negative. So I'm going to reflect my graph over the x-axis. We also have this 2 here. Now this 2 is saying I'm going to take all of my y values and multiply them by 2, as in I'm going to make them kind of higher. I'm going to stretch out my function. So this ends up being a vertical stretch. And finally, I have an x minus 1 as my input, so I'm going to be shifting my function to the right by 1 unit. As always, I like to start off with the graph of the base function. So let's start off with our blue and purple rules. So I'm going to reflect these points over the x-axis, and I'm going to multiply them by 2. Now you can do that in either order. You can multiply them by 2 first, and then reflect them over the x-axis, or you can reflect them over the x-axis first, and then multiply them by 2. Let's reflect them over the x-axis first. So this positive 3 and this positive 3 will then become negative 3's. So they'll be down here. But now I need to multiply them by 2. So when I multiply them by 2, they'll be down here at negative 6. And I'm going to go ahead and erase my intermediary points. But now I have one more rule. I have to shift them to the right by 1 unit. So I'm going to move them over 1 unit. However, I also need to make sure I include the origin. So I'm going to erase my old intermediary points. And now I can connect everything. And that's the graph of our function. Moving on to our last problem, I'm going to follow the same process. I want to write my base function. So let f of x be equal to the absolute value of x. And I want to rewrite my function h in terms of my base function. So h of x is equal to f of 1/2 x minus 1. What's happening to our function? Well, first off, we have this 1/2 in here. So I'm going to be multiplying my input by 1/2, as in I'm going to stretch out my graph horizontally, or you could say a vertical compression. And finally, we have this minus 1, so we're going to shift our graph 1 unit down. Let's start off by drawing our base function. Okay, so first off, we have a horizontal stretch. So it's like we're taking these arms and pulling them out to the side. But what does that actually mean in terms of our points? Well, our points are just going to be multiplied by 1/2. So let's actually plug in a couple points to see what's happening. So what is f of 1/2 times 3? Well, f of 1/2 times 3 is going to be f of 3/2, which is the absolute value of 3/2. And since 3/2 is positive, we do nothing to it, and it's equal to 3/2. So we know that that point is right over here. Now we can do the same with negative 3. So f of 1/2 times negative 3 is going to be f of negative 3/2, which is the absolute value of negative 3/2. Since it's negative 3/2, it's going to become positive. And so we get a point way over here, halfway down. Now we're almost done, but we have one more rule to follow. We have to shift each of these points 1 unit down. So we can shift these red dots along with the origin 1 unit down, and then we'll be able to connect everything to finish our graph. So shifting each point 1 unit down, we're left right there. Now I'm going to erase my intermediary points. And now we can connect everything. And that is our graph. That's going to do it for this video, and I hope to see you in the next one.